Welcome everyone to Foundation Maths. I'm Jason and I'm going to be taking the subject this semester, and I wanted to do a bit of a preliminary week hello, meet and greet, and I've remade this video. I did it early on today and some of you will have seen that, but I've decided to just go ahead and do an office version as well. So the main thing that I wanted to get across to you students today was the appropriateness of believing that this is something that you can do and you can do well. I think that what happens in life is that we get a little bit befuddled from our experiences, and we can't necessarily go back and change things that happened in the past. We just have to try and manage what's in front of us now. So there is something that I want to talk to you about, and I guess that is what presents what presents. Now that's normally referred to patients or people, but I'm thinking about a curriculum system and all of its parts. Okay? And then I'm thinking about your strategic methods. Or your now that's a bit company orientated, but strategic intent won't hurt. So one of the things that happens is that we get a presentation from a curriculum system that isn't always the best thing. And we need to acknowledge that that's the case. There's no point us coming away thinking that all the experiences that we've had in the past are unquestionably the best there are. Now, many of you will have had good positive experiences with staff at school, whether it was recently or decades ago. And I don't mean to change that perception at all. That's very good. But many of you will have had the other part. Now, one of the things that happens in a school is that the coordinators, both of curriculum and mathematics, are constantly guarding against any kind of accusation about academic impropriety or poor performance. And so what that does is it really makes them think about the world through their own lens, through the centric lens of themselves and their school. What that means, of course, is that they don't necessarily come down to a student at a student's level and invest in them. Now, that sounds awful, and others would beg to differ. But in the pressure cooker of a school, it can often be the case that, the imperative is expedited at the expense of the education of the child. That's just an experience fact that I've witnessed. So I've been somewhat of a different kind of person. I'm going to post a PDF. I hope I haven't put the PDF. Oh, I have. So I'm just going to move that screen off to the side. And I'm going to post a bit of a bio for myself, and just to give you some explanation about where I'm coming from and what my thinking and ideas are. And so, in that sense, it's very much the case that I'm a different person. I'm a different person that looks at things a little bit differently, and so that's interesting. So what I'm going to do is just bring this up here, and I use Microsoft Edge because Edge allows me to use bits and pieces of that which I need to do. Okay, so this is a public domain document. I've modified it a little bit because some of it is about something that happened when I was a child, and that's not relevant to you guys. That's not the story we want to be telling. What we want to do is we want to talk about demystifying maths. So the redacted bit is in here, so there's no point chasing all that. I'm going to ask you to just leave it and read from here. So rebuilding from the ground up. And so basically, don't go hunting for the story. Even though it's public domain, it's not about that. It's about mathematics. So essentially what this says is that I didn't get a chance to go on in senior school. I was told to leave and had to do a trade, and then did an engineering certificate at night through TAFE. So that was a great friend of mine at the time. And towards the end of my apprenticeship, I sought to become a cadetship. So I finished my trade and got my trade qualifications, finished my engineering certificate at TAFE, and that was sufficient to get me into UTS as an engineering a degree. So I ended up being cadet engineer for a short time. But then there was a little problem that arose. That was I came to UTS and started working, and guess what? It was too much. I couldn't do it. So I had a bit of a blow. So what ended up happening was that it changed my career. It changed my life because the people that employed me as a cadet said, listen, man, if uni's not going to work out, we can't keep you going as a cadet. So in a way, I guess I lost that. I can say that I translated it to part-time and started working on a degree part-time, but that sort of came later. So what they did, they treated me as an associate engineer and gave me a job as a project engineer. So I was still very fortunate to have a job as a project engineer. And then it wasn't long before that business closed. So I had a good 8 or 9 years there. And then somebody who'd left that business went to another business a few years earlier. And so they rang up and said, hey, we've got a guy who knows what he's doing. But they gave me a start at that rather sophisticated engineering business. So I went to that business and started working there. And I went to TAFE at night to teach a bit of electrical because I'd done that qualification, and they let me do all that. So that was interesting. And in that time, I also did an education degree because I'd felt as though engineering might not quite go the way I intended it to go. And so I did that, and lo and behold, at the end of the time that I was at the manufacturing business, I'd come up with some rather sophisticated electronics to drive a magnetic motor for a particular product. And it was very complicated. And they said, well, you can't do this on your own. We need to get you some help. So what they did, they put me into a CSIRO UTS, Semcor at the time it was called, company collaboration. And so what happened was I came to UTS again. I came back to UTS after a little break. And that's when my world changed. So while I was at the 9 months I was there, working, being paid in a business, and had the privilege of working in the Power and Machines laboratory in the tower as it was then. And I met someone, a fellow who was a professor of electrical engineering, and this guy was the most amazing guy. He was just calm, collected. He wasn't arrogant. He wasn't hyped. He was just, let's have a look. And he taught me a great deal about what it means to be an academic student. In fact, I think he probably filled in my strategic intent without me really knowing it as a young man. Still, well, at that point, because of that project, I went back to my workplace and I was promoted to be the chief engineer. I looked after manufacturing, which included lots of different trades and associate and degree qualified engineers and tool rooms and all the like. So a big variety of engineering activities. Such was my desire to get on and just do what was needed to do. So I spent lots of money on capital projects, but also, a big part of engineering is you do projects that make a profit and you turn them back and they become profitable for the business. So I spent $1 million, but we gained $1 million in costs, savings in costs every year. So that was a huge return. That's how capital systems kind of work in a way where investment reaps a return, and engineers can be at the forefront of that. Now, what happened, of course, that business went up. So I was made redundant. I put my little thing aside to do teaching, so I went and got a job as a teacher. And my first job was in a school teaching TAS, and of course that kind of went with the variety of engineering that I'd done, and computing, because I'd always done a lot of computing. And then I was offered a job as a maths teacher. So they said I had to get a proper maths qualification. So I kind of went, this will be interesting, because my last foray into maths at UTS wasn't so great. But I'd been teaching at the time, kids in 7 to 12. I'd started teaching senior maths, and it all took. So all of a sudden, I kind of laugh in that, although I was a poor kid brought up, I got a private school education. So I know some people would cringe at that. But the beauty of it is that I did manage to come to an understanding about what was needed. So I did I just progressed. It was the same as when I was in industry. I just progressed. I did senior maths, taught senior maths, Extension 1, Extension 2 for a number of years. Became a deputy principal, ran the school. Everybody go here, everybody do that. You can just imagine me running around and organising all that stuff. So that was interesting. And then after that, I got my own school. I got someone rang me and said, "Hey, there's a thing going. I want you to turn up." So I went over to a place and got my own school. So I did that for a couple of years. Now the thing about that was a humble school compared to the previous one, a bit hoity-toity, the previous one. And this one was a humble school, but the results were far better than the hoity-toity school. And I needed to understand what was going on. Why was it possible for me to teach Extension 1, Extension 2 in a school to kids the way that I'd done it in the hoity-toity school, and then to teach it in the more humble school, and they were actually doing better. So what was going on? What was the mechanism? And something sparked inside me and said, look, you've got to work this out. So it came to be that I came to UTS, came back, and Mary Copeland is a name that you'll hear. So you can all blame Mary for me being back here. And what I ended up doing was some work, doing some short courses, doing some research work for her, gathering data, building up the MRS and the website and all of that stuff using all the computing skills that I'd had. So with the short courses, I started to develop a sense of what was needed, that how do I get them to perform? Because in the school that I was in, we were getting kids getting 100% in Extension 1 and 2 and very high results, not just your 90s, but very high results. And so I'm going to come back and talk about that in a minute because it is important. But anyway, what I do, I got basically to 6 steps of maths that you need for success. And I think with the time that I've spent, I've tested over 11,000 students. I've helped an endless number of students out of standard maths and general maths into the calculus maths at first year university. And anecdotally and even empirically, there's evidence that the 6 steps are exactly what the doctor called for. Now, how they get them in school, in the rush and the hustle, the absolute pressure cooker of a top 50 school, it comes innately in the way that they do their work. I'm not sure they do it explicitly the way I do it, but certainly it comes out in the wash that they need these things, and they're usually very good at doing these 6 things. Although they probably couldn't name that. That's what they can do well. That's the irony of that. So the purpose of the testing and the reason that some of you have ended up in foundation maths is because really it's my fault. You can blame me. I caught you, right? I caught you and I said, we need to get you some training that'll help you thrive in mathematics at university. So that's me being a mathematical friend. Now, I'm not your friend in the sense that we're going to go out together and have a beer or whatever, but a mathematical friend. A friend, not your judge. I'm not here to judge you. I'm here to help you get settled in this rather challenging sphere of university-level mathematics in the first year. And so we know for the people who can do it on their own, that's great. But for the rest of us, we've always needed a little bit of help. And if we can get that help, we can move forward. So here I am. The purpose of it, this is the MRS I'm referring to, is to catch me back in the 90s and pull me aside and say, you know what? This is not beyond you. This is something you can do. You just need a bit of training. Okay? So I'm not going to hype you up. I'm not going to tell you you're the best and your natural talent and all of those things that you had when you were young at school. None of that's relevant. We're not looking beyond and backwards. We're just looking forward and saying what we'll deal with now is that we'll get some training, and that training will help us succeed. So the mystery of mathematics is being conquered to some degree, and usually students who work with me sorry, somebody just jumped in there. Sorry, I just can't take this at the moment. I'm in a meeting. So that'll probably ring again, but I don't know how to turn it off. All right, so a bit of fun for the video. Okay, so in that sense, what is it about these 6 things that make an important difference? All right, well, the curriculum will present itself And we can't be too harsh on the people that are doing that because it's a big job. All right, teaching mathematics in a high school, they deserve a medal. They're all my heroes as far as I'm concerned, despite what I've said about using professional judgment to guide students here and there, which I'm not a big fan of. So I'm not a believer in grading systems. So in that sense, having said that, this gives you the opportunity to learn about maths using a different style. So the way that a curriculum system presents itself is that we could just give you a textbook. We could just say, here's a textbook and away you go. You can just study it and that'll be solved. Or in our case, you can go into Pearson and do what you need to do in Pearson and that'll be the solver. I mean, I've got the foundation outline here and we can go down to all of the things that all of those things that and we can find the reference text. And so just excuse me for one moment. I'm sorry I can't take the call. I'm just in a meeting. Okay, so I don't know how to turn that off. I reckon I could do that and let's see what happens. All right, so the text, I could give you the text and say, yep, that's your text. Away you go, Washington, and you can do that. Okay, so that's interesting. But is that going to be the answer? Is that going to be enough? Okay, some resources are awesome. So, for example, before I get to the plethora of resources, I just want to stick with this curriculum system. Now, the HSC is about this wide. So it's got lots, and this is in the video if you've seen it, lots and lots of material. The Maths 1 course is about this wide. Okay? And what we need from the Maths 1 course, we just need you to be able to do it really, really well. Okay? All this stuff out here in the wing, you may come back to it at some point in the future. And a large part of the HSC competitiveness is built around two ideas. They used to call it Part A and Part B, problem solving, and just, but I want to suggest that you've got your normal know-how components, normal know-how to do things, but then you have analysis, and most of the problems, most of the problems are bound over in problems related to analysis. And fortunately for you, that means, of course, that for Maths 1 and Maths 2 and for Foundation Maths, we're not going to go over the top on the analysis component. Okay? We're just not going to do it. So this is where the competitive urge comes from. This is where the discipline specialist comes from. Okay, so the discipline specialists, even the ones that do applied mathematics or other specialisations, they come from a deeper knowledge of analysis. Okay, for the rest of us, we can go off here and do engineering, science, and various things. Now, the pressure for that comes from there. So in Maths 1, the analysis component is not as high as you would expect even for the HSC. I mean, I can give students from Maths 1 analysis type questions from 4-unit maths, for example, or even 3-unit maths, and they won't be able to do them. Okay. So the thing is, who cares? We don't want to do that. We don't want to be bothered by that. What we want to know is go, oh, okay. So provided we learn this stuff here, happy days. We're going to be able to do Maths 1 and subjects like that in the future. So there's a fair bit of work to be done still to get this right. But how do we do that? What's the approach? What is it about that will cause us to have success? So one of the things that we'll look at is just some resources now. I'll go to the strategic intent in a moment, but I just want to go through the resources quickly. just going back to the maths website, and what we find is that under resources and the library there, resources library, and this bridging thing, what we see is that we've got a whole bunch. Oh, look, algebra 1, algebra 2, doesn't look familiar. Graphs, logarithms, tree, different. So that's like a little library thing you can go to yourselves and have a look at. But I want you to show, look at this column. 120,000, 160,000, 153,000, hundreds of thousands of hits, 208,000, hundreds of thousands of hits of students wanting to learn about the topics that you guys are learning about. So that's developed over a number of years, granted, but nevertheless, the hunger and the thirst is there. So you can use that as a resource anytime you like. You don't need to buy it, or you just hop on and away you go. All right, the other thing I want to bring to your attention in terms of strategic intent is there's a couple of things that we need to get right. In order to pick this up, we need to get a couple of things right. And if we have a look at the MRS, not the practice test, but this page here, what we find is that I've written some stuff here about what it takes to succeed in first year mathematics. And this is my conviction. This is what I've been working for more than a decade. Now, who would have believed that adding fractions, really? You're kidding me. Algebra 1 and Algebra 2, and you're saying adding fractions. Well, I'm going to show you this semester. I'm going to show you how important this is. And I'm going to show you how it gets lost. I'm going to put it in there, and I want you, this is, in a way, this is your job. Your job isn't the noise, isn't the textbooks, isn't doing Pearson. Oh, you've got to do all that stuff to pass the subject, but this is your job. You've got to learn all of this. And then we've got all of the other things too. Indices, for heaven's sakes. What have we got to know about indices? Isn't that just part of algebra as well? And what's the big fuss with linear functions and their graphs? Or quadratics? Why on earth? Okay, what's all that about? So I'm going to deliberately line these out for you. Okay, functions and graphs. Functions and their graphs. And E and X and the ln of X. But importantly as inverses. Oh, there's a word that sends a shudder down the spine. Inverses. What are you talking about, inverses? And then the most important thing that I can give you is this thing called exact values trigonometry. Okay, all of the things that are hard in terms of extension 1 and extension 2, they need this. Now, this is the only topic where I ask students to learn it by rote. Everything else I'm happy for the discovery process to unfold, but that one there is the only one that I say this has got to be done from memory. So we'll look at that in the future. Now you'll notice that in this list, where's the calculus? So I've prepared students to go into Mathematics 1 who've come from a background of general or standard and taught them these 6 things intensively and got them going, and they've been able to go into Maths 1 and learn calculus, which they've never done before, and at the same time pass their subject. So this is quite a big deal. This is a lot to hang your hat on. There'll be a lot of contemporaries of mine who won't do this. They won't put their hat on the stand and say, if you do these things, guaranteed, you can't guarantee anything, can you? The success that you'll have in first year. So that's the parcel that we're going to unpack this semester, and that's what we're going to be learning about. So what I wanted to do, because I've spent quite a bit of time with you on this already, so that will mean that I want to be a little careful about how much more I do. So what I'm going to do is take a look at some work that will come out of Maths 1 and something that you would do in Maths 1. Now, my point isn't to, oh, let's do Maths 1, Maths, we're supposed to be doing Foundation Maths. My point is to point out to you what's in Foundation. Now, these 6 things, there's a couple of attendant helpers along there. and I'll increase this list. But recognition, I spelled that out in 6th class once, also forms of equations and expressions. Okay, the forms of those equations. These are the kind of other things that you need to learn apart from your 6 things. So when you take an appreciation of those things and your 6 things, then you can start to build. Now, what happens when we get into a math class, we hear something or see something we don't understand? This happens, we pull this up, and it's like, oh, what's happened? This is horrible. I can't understand this. I must be something wrong. Well, we've got to move away from the idea that you've made a mistake or that you're not suited. Remember that head teacher that said you go to that class? Well, that's irrelevant now. Okay, what we're saying is that we're just going to train you what to do. So in a way, that's a good signpost. I don't know what to do. That's a good signpost because now the response to that is I need some training. So if you get the training that you need, you're going to recognise future versions. If you get the training that you need, you're going to recognise future versions, and so you'll be able to dive in and attack them. So if we think about recognition, if we think about being, say, somewhere like Olympic Park there at Homebush, and we go and there's thousands of people out spread around, and we're there, whoever we are, and then we hear a voice and it's a member of the family saying one of their loved little ones is missing, and we all need to look. Stop where you are and look. And of course, the problem with that is if we look for their loved little ones and we don't recognise, we're doing this, we're pulling up a blank. There's no way in the world we'll be able to say, there's your little loved one. We won't be able to do that because we won't see it. Now, this has been going on in math class and goes on in math class today, unfortunately, far too much. And so when you get into a class and your little loved one is up on the board and you don't recognise it, to pull apart. So the pulling apart of that means, of course, that we've got to learn to recognise certain things. So we've got to take that on with strategic intent. This one here has to be our strategic intent. We have to learn to develop these ideas in concert with our 6 things. That's kind of a practical way to do things, which is great. It's a wonderful way to do things, but this is all important here. All right, so I think I've probably gone on long enough, and I think you've got a fairly good idea about where I'm at and where I'm going. So what I'm going to do is an example out of Mathematics 1 and try and point out for you, highlight for you the attendance skills that you would need. So if we have something like, let's do the one down here. So we came down here for a look at this, didn't we? So we've got, this one here. So let's see this one here. Let's look under the hood. Let's be a mathsy person. Let's be a mathsy person and understand how this happens. So here's an example of this. So we've got sine to the -1. Now the inverse operation of integration is differentiation. So what we're going to do is we're going to differentiate this. Now I don't care if you don't know anything about differentiation, even if you know what it means. Okay, its definition, I don't care. I want to understand what's going on from my 6 things. So the first thing I'm going to do is I'm going to do what we would call undo. Now, undo is one of the things that we will learn in our part. This is undo. Now, you've been doing it for years with equations, simple equations, but that needs explanation, and we'll do that in the coming weeks. Okay, so undo. So that's number 1 from the 6 things. It's part of the. All of them. Okay, it's part of all of those things. So the next thing then, if we've got sine y is equal to x on a, so then of course I'm going to square both sides. It won't be apparent y. Now that form might not look familiar to you, so that's another one. How on earth did I do that? That's another one. So there's 3 hits, 4 hits from foundation maths that we haven't yet learned, but that's what we need to recognise. And then the next thing I'm going to do is I'm going to differentiate this. And this is another hit. Look, it's a form of an equation. Who writes that? That's the expression form of differentiation. Okay, that's the expression form. And we're ddxing everything with respect to x, all of those terms. So if I go and put dd something in here for sine, well, that's hardly seeming right. ddx of this one makes perfect sense. If you've done calculus, if you haven't, what? So this is our normal run of the term. X over a is a constant. So the ddx of that will be 1 over a. So that's good. That was the one that we learned at school. Maybe. dd what? You can't ddx of sine y. So this brings another one. So now we're up to 6. We're up to 6 times where we've got to do the 6 things, 6 of the 6 elements. So this time what would make sense? Well, what we're going to do is we're still going to have ddx. There it is, the long way. Okay? But we're going to have something else up there. And the something else that we're going to have, what would make sense? It would be y, wouldn't it? So this is an invocation of the chain rule. dy dx. Oh, dy dx. So now that one makes sense. We're making dy, but we've still got dx because our original thing was to differentiate with respect to x. Differential sign is cos, so we end up with cos y dy dx. So there's our dy dx. It looks like we've found our dy dx. But we'll just do one more thing. Again, from our 6 things, we will have moved that around. How did you do that? So we will put that together, and that's what it looks like. So that's our differential, dy dx, and 1 over a cos x. I'm just making a video. Sorry, guys.
Some students.
Yeah, they'll have to wait.
Okay.
So we've got dy dx, which we found, and so we've got now our equation's no longer in the form of x. We've got cos y. So what we've got to do is come back up here and sort this out. So again, this is the exact values tree one. So none of this will make sense to you if you've done standard maths, and that's not my point today. It's not to upset you. It's to help you see within a problem. Here's another one that I'll do from our values, valuing our, I'm just going to leave that as empty. It could be theta, but it could be some other variable. And sine. And so now we've got sine squared. So there's a sine squared. So we're identifying forms. But I need it in terms of cos. I've got a cos there, but not a cos squared. So I can rearrange this to be cos squared is equal to 1 minus sine squared. Oh, I can replace that one. But before I do that, I want to make that a cos. And so 1 minus, now I can replace that. And I've got x squared over a squared. Very good. So now I can replace that cos y with this one. I can, because I had a y up there, didn't I? It was a sine y. So it became a cos y. And because I made a substitution for sine y, it moved from sine y to x and a. So all of these things compound. Now, if you're not familiar with any of the or any of the 6 things that we've done, you'll be sitting there lost going, Jason, what are you doing? And what I'm doing is highlighting this at least 11 or 12 items out of foundation maths that we need to have nailed in order to recognise their use here. So I'm going to do it one more time. So here we've got 1 over a, the square root of 1 minus x squared. Now this is an algebraic thing. We'll cover all of this in the future. But I want to think about that 1 minus x squared a squared. And how do I make that a fall under a radical square root sign? Well, I do that. There you go. So now there's a rule that says if I've got the square root of something multiplied by the square root of something else, I can put them under the same thing. Okay? So I'm going to put them under the same thing. Now this is joined together by a minus, so here's another algebraic issue. So I put a bracket in. So look at all the algebra that's needed. We've done all the calculus. It's the algebra that's hanging us up. It's the algebra that's causing us the grief. So we've got to learn all these things. So we'll do the expansion one way and then the other. So we'll get a squared minus a squared times x squared over a squared. Now who can see what's going to happen? They're going to cancel. That's another form of 1. 1's my favourite number. A squared minus x squared. So that whole denominator becomes the square root of a squared minus x squared. And so dy dx or y dash is equal to this one. Now if we integrate this one, dx, we will get sine to the minus 1 x on a plus c. So we just did it backwards. Okay, we did it backwards. We started with this and differentiated it, and we got this result. Okay, so this is the table. So hopefully that's giving you some insight into looking under the hood and seeing the horsepower of mathematics. And in a way, I don't care if you didn't follow all of those steps, but look at all the steps that we did need. The background information is related to these 6 things. It has very little to do with the actual differentiation. From this step to this step, we did calculus. Okay? From this step to this step, we did calculus. Okay? From this step to this step, we did calculus. Here, we've shown now that we've got ourselves that. Okay? All right. So hopefully what we've recognised is that in all of the complexities of a Maths 1 problem, we've got some things that we've got to assemble and do. So I appreciate you coming. I'm going to pause there because that's coming up to 40 minutes, and that's more than enough of an intro video. So welcome to Foundation Mathematics, and I trust that you'll enjoy your time with me, that you've seen something different, and that you'll be able to walk with me gently, and we will discover these things that we need to succeed in Maths 1 in the future, and certainly you will succeed in Foundation Maths. All right, bye for now. Thank you.